Well, oh, an error it says, and other people says go live. So we'll take it that we're live. One thing says an error, one thing says live. You say this, I say that. Here I am with Jorrit Linders, CEO of Acecore Technologies, and they're the people that build those weird crank-armed multirotors. So there's the first thing we're going to know is why on earth the crank-armed multirotors?
Well, basically, when we start being in this market, we saw a lot of, let's say it in a rude way, maybe like Christmas trees flying around. They had like all like these tube frames and like the more like easy standard off the shelf carbon fiber parts, where we felt like we really wanted to make a change in that. So we really like put a lot of design, airflow, and artwork into our frames. So we use like the highest type of carbon fiber technology to actually create these crazy shapes. Yeah, we're very proud of how the drones are looking. But besides that, they also have a better way of performing. So we can basically build the electronics more covered. So they're very protected by dust, rain, and all these environmental impacts, which normally could cause like damage to your electronics. And on top of that, we can cancel out more vibrations than like a standard frame as well. So I feel like
Hang
that's
on, just unpack me for that. Unpack that a second for me, Joe. Are you saying because the propellers are beneath, you're not quite getting the flex on the frame, and that's reducing that, and your aerodynamics is because you're dragging the air past a long thin surface rather than round a big fat tube. Just from my understanding.
yeah, correct. And also because our frame is hollow on that way, it's because our frame is a bit bigger, of course, than the normal conventional ones. But of course, when we like covered the electronics inside this carbon framework, we of course had these challenges that the temperatures of the electronics needs to be cooled. But we by doing the design we have now, and that having the motors upside down and having a hollow airframe, we actually in from the inside, it's actually kind of a vacuum cleaner. So there's actually airflow going through all the electronics and
Okay.
being sucked out by the motor on the end. So basically, on every part, we've thought about like a lot of times. And in the end, that makes our frame definitely different than from all the others in this industry.
I had no idea. That's very cool. So it's some sort of slotted. Now I'm going to rant on because I'm interested in this. It's some sort of slotted design that drags the air through it past the electronics and then cools it.
Correct. Um,
Wow, I never thought of that. That's very cool.
yeah, it's
All
true.
right,
And
I'm
then
convinced.
and then of course we have the benefit of that we can actually fly in like these crazy conditions, like a heavy snowfall, wind, rain, sand, salty environments, because the electronics are more covered than like most of the other frames. So that's also for the lifetime of the product a much better solution. So
Wow, that's amazing. Yeah, I see that's one of your claims, isn't it? Is the weather stuff.
yeah,
Um, and
correct.
on your website, you also quote no more flight anxiety, up to 265 minutes of flight time. Now, how do we do 265 minutes of flight time?
Yeah, obviously we started with the batteries in the beginning as the main power source for a multi-rotor. But like more people doing now these days, it's the hybrid comes in and takes definitely this next step to flight time. So we have a hybrid combination of electric backup batteries in combination of a combustion engine on top of the drone, which then creates or generates this electricity for the drone. And with this combination, basically by just burning fuel, we can just have this amazing flight time of like over 2 hours, 3 hours even these days. So yeah, that's incredible.
That's quite a chunk of payload, though. So what are you left, or quite a lot to lift on its own? So what are you left with payload wise once you've lifted all that stuff?
You're still easy capable of bringing up 6 kg payload, and that 6 kg payload is then also for a 2 hour flight. It's not that it will then have only 40 minutes left. No, it's still with that 6 kg payload. We get this over 2 hour flight time, so it's a decent payload. It's the most common payload range for all these LiDAR scanners or cameras we put under these drones. So,
And well, I suppose here's the question, if you don't mind me asking: what sort of flight stack do you run, and what sort of autopilot do you use?
yeah, we use the Cube Orange, the Autopilot stack. It's been there for a while. It's just the best piece of equipment, I feel like, for the open source development industry. But we took a big step with bringing that, let's say, the Cube, that hardware into our frame and standardize it. Fully tested it, make a lot of hours on it, and then we actually finalized it and certified it in let's say in our own way to have this as the main standard flight stack for all our platforms. But because it's just so reliable, it's super easy to fine tune for these different payloads, and this is why we really like this type of hardware and stick to it. So.
And well, I'll ask Louis' question first. Louis in the chat: how do you manage motor failures?
Yeah, we obviously the Autopilot stack has a very good algorithm already by detecting a propulsion loss if we would have one. So the system, we've actually done a test and showed that also in public on YouTube, that we are capable with a fully payload, let's say our biggest drone, the NOAA, with a fully equipped NOAA drone with, let's say, I think it's like 400,000 euro LiDAR underneath. We just shut it down, the one motor, on purpose, and then you can see how actually super stable this platform becomes, and we are still capable of landing the drone safely back to the return to launch point.
So it will detect that in real time,
exactly.
And you'll be alerted, and then you'll be able to make a landing on 3 motors. That's amazing.
Yeah, well, actually, it's 4 motors. It will shut down like 2 motors almost, and then it becomes, let's say, an unstable quadcopter. But this shows how these algorithms are so well developed. So, and this is really needed for safety. So we're very happy with it.
Don't you want to we'll just go a couple more minutes? Don't you want to bring that in front of you and show us that, or you're hiding your machine behind you?
Yeah.
Can't you take a look? Please show us off the stack. It seems a shame to keep it hidden there.
Yeah, so this is one of our systems. Obviously, it's quite hard maybe to see and
show
you on camera like all the details, but you get an idea of how it looks like. It's obviously very light because of all the carbon fiber work. You can see it better now.
Yeah. And those arms, I see they're racked up behind you in a row. Do they just plug in?
Yeah, so basically what we have on the back is one of the arms, 6 of the arms we have on the NOAA. Let me grab one. It's basically a chart which comes from the production side. So it's basically how we roll them into production. This is almost like a finished product already. You can see like the nice finish we put on the arms. It's every drone has like a custom color. It depends if the customer is asking for it. Otherwise, we stick with just the matte black carbon fiber look. But you can do like duotones for if you want to have like a more heat protective coating on the top surface. For example, if you would fly in like the Middle East or the hotter areas on Earth. But yeah, every part you see and what we have here in house is custom made by us. Is custom designed like maybe we have like go over every single part like 3 or 4 times to reduce weight. And this in the end makes this product so good, I would say, to compare to. We put a lot of love and energy in every single piece of the design. So.
And where's the I've been trying to. There's a reason for the TikTok orientation, but I can't tell you the reason. So can you? Is that secret sauce how you drag air through that arm?
No,
can you show me, or is it?
Yeah, I can actually show you. So basically, if you see this, like it's a hollow. It's a there. See, it's
there we go. Yeah.
So the walls are very thin, like because we can, of course, don't want to bring up extra weight. But this is like completely hollow. So as soon as this motor starts to like, let's say let's say, goes like turns, airflow on the scoops of the motors are being swinged out, and it also creates a different pressure area, and therefore all the air which is being sucked out down or being pushed down by the propeller is on the, you see on the surface of the motor,
Yeah.
like next to the
Yeah.
motor, there's like a gap, and then which basically sucks out the air which comes from the whole inside of the boom. And that boom is then already connected to the center core of the drone, where all the other electronics are placed, and that brings that let's say airflow.
So you're actively dragging the air out of the center of the machine to cool it all. That's very cool.
Exactly.
No pun intended, but yeah, no, I get it. And did I see like a wire cutter on that arm or something? There was a hook or a hatch, or there was a clip or something on the other side. I'm terrible. I'm also gone over.
You mean on the back, like this side?
Oh yeah, that's what I saw. Yeah. Is that a clip?
Yeah, it's basically to detach the arm to the centerpiece, so it's easy. We made them all interchangeable, so it's easy for transport. Also, if you damage one arm, it's easy to replace one. You don't need to buy a whole new drone. So everything is modular, designed in that way.
And all of this can be found at acecoretechnologies.com. I believe that is your website. Go on, frighten me with the price then. Frighten me with the price of a simple base unit for a simple country boy like me.
It's hard to say. I mean, with these days, the payloads and all the additionals will bring up prices like insane. Like I said, we have payloads over 400,000 euros. But let's say starting from like a base platform, we already have like a complete solution around 20K, all the way up to 150K. This is about the range you're talking about if you go for one of our systems.
Well, Jorit, that's amazing. I have limitations on the time of this for reasons, dear viewer. Jorit, thank you very much. I might have a few more questions for you. Look after yourself. We'll see you soon. Thanks very much for your time, Jorit. Cheers, man.
Thanks.
Bye.